Hi, I'm Richard from Plant Photonics and welcome to the second in our series of videos on how to make your own high quality LED grow light. In today's video I'm going to show you how to go from this, the bare circuit board, up to this one with the LEDs soldered in place. Now in order to do that we're going to be using this stuff. This is the solder paste which I introduced in the first video. Now the first thing we have to do before we can use it is open it pretty obviously and then give it a good stir. Now the reason for that is, you can stir it with anything, it's not particularly critical. The reason for that is that solder paste is composed of two parts. One is the powdered metal and the second part is what's called a flux. Now the job of the flux is to clean the metal of any oxide and to help the metal spread out evenly across the contact points. And because lead is extremely heavy, it tends to sink to the bottom of this, and you wind up with a layer of liquid on top and powder on the bottom. You need to mix them together and make sure that they're thoroughly mixed. Now another thing that we're going to be doing in order to make this is we need to take a small dollop of this out and put it on something like this. Doesn't really matter what it is so long as it's not absorbent. This is a spatula. And you're going to have to mix it again. You're going to have to mix it like this or do it like this as well. Just stir it around. The reason for that is that solder paste is what is known as a thixotropic liquid. It's a bit like quicksand. When it's sitting still, it goes fairly stiff and hard. I mean, you can walk on quicksand. It's only when you start moving around rapidly that it starts to liquefy. This stuff is the same way. In order to get it onto the circuit boards, we need to have it nice and liquid. It's actually really cold where I'm filming this, so it's not cooperating very much. I'm going to have to warm this up. But anyway, and when it's thoroughly mixed, you can see it sort of starts to become stringy and stretch out like that. That's what you want, because you want to get a little point of solder hanging down like you can see here and carefully dab it onto the contacts. It is a pain, I will admit, but it's the only way that you can realistically do this. Now normally if you're doing this sort of thing, I have to zoom out here so you can see a bit more of it. This is a solder mask, okay? It's a sheet of stainless steel and it's got these little holes in it that are actually cut out with a laser. And under normal circumstances, you lay this on top of your circuit board and you literally wipe the solder paste across the top with a squeegee. You need a machine that holds both this and the circuit boards. And it just leaves an exact print. It's exactly the same as silkscreen printing. It leaves a print of solder in exactly the right spot, in exactly the right thickness. This is about I don't know, 1/4 of a millimeter or something. Yeah, it doesn't actually state on these ones. But anyway, that's what you would normally use. If you're going to be doing... Okay, so that is what you would normally use. If you're going to be doing a large number of circuit boards, then another way you can do it is you can actually just put this on a scanner, scan it, print it out onto transparency, overhead transparency plastic film, and very carefully cut out where you want the solder to go. And then you can put it over top of the circuit board and put the solder paste on. That is a lot of work, and you also need to build some sort of jig to hold the circuit board and hold the plastic. So it's only something that you do, even if it's just made out of cardboard and sticky tape, it's only something you do if you're going to be printing quite a lot of them. For a small project like this, it's better to just dab the stuff on. Now, I wanted to show you me actually doing it. However, due to the limitations of my video camera and that, it's not really possible. So basically I'm going to show you some photographs of a couple of circuit boards that I've done so you can take a look at the amount of solder paste I've put on. The first one actually is, I've got a bit too much on there, but it doesn't really matter. Now when you heat these up, the solder will turn into a liquid and it will flow across the metal. It will not go outside the metal, and if you've got any, for example, on the white part of the circuit board, it will get sucked in to where the metal is. You really need to make sure, more than anything, that you've got a reasonably even amount on these. You want an equal amount on each side on the two contact points, and then a dollop about twice the size in the middle. That's because there's a much larger area, twice as large, for it to spread out. Alignment, when you put the LEDs on, isn't that critical. You want to get it as close as possible. You should be able to at least see these little points here on either side of the contact and get it centered. But the actual surface tension of the liquid will actually tend to pull them into alignment. They are actually self-aligning. If you look at this circuit board, for example, the LEDs are absolutely perfectly square. They didn't start off that way, but after being reflowed, the solder melted, they went into correct alignment. They were actually pulled in by the liquid solder, which is trying to pull the two metal surfaces as close together as possible. So it's not quite as touchy as you might think. The main danger is getting a bit too much solder, although again that's quite difficult. You'll see what happens when we reflow some circuit boards that have got a bit too much solder on it, and you'll see that the solder pretty much gets squeezed out the sides. It doesn't go underneath. So again, the quantity is not quite as critical as you might think, although it's a good idea to get it as close as possible. Now, for putting it on, you can use something like just a piece of thin wire. You need something reasonably rigid. This is a dispensing needle. It's like a normal hypodermic syringe, except it doesn't have a point on it, because it's for dispensing glue or whatever, some kind of chemical. Or you can use this, which is a standard fairly large embroidery needle. You can use either end, either the sharp pointed end or the back end. Experiment a bit and see which works best for you. Okay, so I'm going to go put some solder paste on some circuit boards and take some photos, and I'll talk through what I've done and what I think of each contact point that I've done, as far as too much, too little, whatever. It's very difficult to get too little, especially on something this small. The main problem is getting a huge amount. But again, as I've explained, it's not that critical because of the way the solder tends to align and pull the circuits, the lead onto the circuit board. If you put too much on, if you put a really large amount on, you get what's called tombstoning, which is where the solder forms almost like little bricks on there and raises the lead up sort of like 0.5 millimeter or a millimeter above the circuit board. You don't want that, because it cuts the ability of the lead to get rid of its heat into the circuit board, because lead's not a particularly brilliant conductor of heat. So you want to err on the side of caution, really, when it comes to putting on the solder. Right, I've put the solder paste on the boards, and I've chosen two as good examples of the sort of quantity that you're looking at. I've got this one here has actually got a little bit more than I would have liked. It's at the higher end of what I'd consider to be good. You can see there's quite a bit on. However, I got the proportions right, and it's not really as bad as it looks. Remember, this is blown up quite a lot, the image that you're looking at. So I'm pretty confident that that'll work quite well. Now, you can see these little metal tabs coming out on the side. Those are actually to help absorb any extra solder, give it a little extra space to flow out. And I've done something else. I've put solder on these solder tabs on here. Now, I didn't actually do that to make it easier to work with later or anything like that. I actually did it as an indicator to let you know when to let me know when the solder is actually melted. You see, when you've got the LEDs on here, you can't see what's going on underneath. So what you can see is these tabs with these dollops of solder paste on it, and when these have melted and flowed out over the tab, you can be pretty darn sure that these are as well. It's usually a good idea to leave it for an extra minute and crank the, let the temperature go up to the full, to 200 and about 200 degrees, just to make absolutely certain you're not going to do any harm. And it always plays to be safe, better than sorry. So, but these give you a visual indication. Now let's take a look at another circuit board. Now this one is much better. This one is much more the sort of amount that you want. Remember, this is going to be higher than it would be if it was put on using the stencil. The stencil is very thin and limits the height. So this is, although it looks like there's not very much on there, there's actually quite a bit. So this is about what I would consider ideal. Okay, now I'm going to go put the LEDs on, and then we can carry on with reflowing the solder. Okay, now I've loaded these onto the grill. I'm using the grill for a couple of reasons. One is it allows the heat to, well, mainly because it allows the heat to rise up. Otherwise I have to heat up the whole grill pan from the bottom before these start to heat up, and meanwhile they're getting heated from the top. I want to try and keep this heating as even as possible. Now I've also put them in the center, and that is because, let me open this, you can see in here, this is the heater element, there's another one at the top, and they're both concentrated in the middle. So I want to keep it over there so it'll get heated up as well as possible. Now I'm going to put these in, and I'm going to put them on the bottom. There's two levels on here, and I'm going to put it on the bottom one. The reason for that is that I want most of the heating to come from the bottom. Actually, I'm going to shift these back slightly. I want most of the heating to come from the bottom because the amount of heat required to heat up these circuit boards to the correct temperature is a lot more than it's going to take the amount of heat coming in to heat up the LEDs to that temperature. So we've put them over the center. It doesn't really make a huge difference, to be honest with you, but I have a mild OCD, so I always try and get things as perfect as possible. So that's fine. Now we want to set the temperature, and I'm going to set it to, the solder actually melts at something like 168 degrees centigrade. Okay. You really want to take them up to probably around 190, 200 degrees to make sure that they have reflowed properly. As I mentioned before, I've got my little solder tabs on there where I can see them, so I'll know when the reflowing is complete. So I'm going to put these on, and I'm going to set the temperature here to about 100, and first I'm going to set it to about 170 degrees, which is pretty much where I should start to get the solder flowing, and then I'm going to increase it slightly to about 200 degrees once I reach that point. I want to try and keep it. This isn't critical for the LEDs, but if you want to use this method to do anything involving like microprocessors and stuff like that, Arduino, whatever, you want to get the temperature hitting its peak for as short an amount of time as possible. So time to plug this in and switch it on. Okay, this shouldn't take very long. I'll just start this off going. It's fairly primitive. It runs on a timer. Okay, you can see it heating up there. There's no way I can show you enough detail about what's going on inside to make it meaningful. Okay, we're a couple of minutes in now. I've shifted the camera slightly so you can see what's going on here. And now I'm going to increase the temperature because it's pretty much hit its target temperature. The solder paste is spreading out, but it hasn't actually melted yet. It's just the flux becoming liquid. Okay, we're starting to get the melting, And yeah, okay, fine. It's suddenly just tipped over the temperature and everything is now melted. I'm just going to leave it a little bit longer to make sure that they're thoroughly and evenly heated. And everything's looking very nice at the moment. This looks like it's gone perfectly. So what I'm going to do now, I'll wait for the element to shut off. And cool. Now I'm going to switch everything off. This doesn't actually have a power switch, so I'll just unplug it. And now, to let it cool off, just open the door a little bit. You don't want it to cool down too fast. You just want to leave a little gap like this to let the hot air out. The reason is that the metal will contract, the circuit board will contract as it cools, and it's best if you let it do it reasonably slowly. So that's it now for the reflow soldering, and let's see the results. Okay, so this is the end result. We'll have a closer look in a moment, but as you can see, the extra solder I put on has melted cleanly on all of these, so we know that the soldering is complete. We'll take a closer look at those in a moment, but this looks very good, and also test them. Well, now the leads have been soldered on, we can have a look at the end result. Now I'm going to show you the same two circuit boards. This is the first one that had quite a lot of extra solder on, and as you can see, the solder's been squeezed out of the edges. You can see these little balls of solder, but on the whole it's looking pretty good. You can see that the leads are flush with the circuit board. There's not any gaps or anything underneath, so it's not sitting up on top of a pile of solder, and they look even, which suggests that we've got a nice solder joint in there. The reason why these look a little bit ratty is I have actually already tested it, and when you melt the solder you wind up with a layer of the flux on top, and it's hard to get good contact through it, so I cleaned it off by sort of stirring it around with the end of a hot soldering iron to expose the solder, and I was able to check it, and yes, it does work, by the way. And now this is the second one, and as you can see, it looks a lot neater. There's virtually no solder been squeezed out on these, and again, they're nice and flush with the circuit board. So as you can see, you don't really need very much solder. I've also tested this one as well, and yes, it worked perfectly as well. Well, now we've got them out the oven. There's only one thing left to do, and that's to make sure everything worked. I have been with a knife and scraped the flux off of these contact points because I wasn't able to make a good contact before. I'm also running these at low voltage so we don't blind the camera or me. So yeah, that works. That works. These are the two that we've been looking at in detail. Yeah. And the last one. Yay. So they all work perfectly. So not a bad result. So it's not as hard as you might think. And that's it for this video. I hope you've enjoyed it and realized how easy it is and possible it is to do your own reflow soldering at home with just basic stuff that you already have. And in the next video, we're going to be putting all of this together into a functional light. So please subscribe, please click like if you enjoyed it, and I will see you in about a week for the next video. So good luck and happy growing.